For the last couple of years, I've been doing a lot with video, and if you dive into video on Apple platforms, you run into stuff like this, and it's a whole lot of stuff, and when you first see it, it looks very complicated, but it turns out it's not that complicated if you, you know, learn what it all means. So I want to go over some of these things, but I want to go back first to start at the beginning, go back a lot. So in the 1800s, people started making photographs. The first photographic devices were created. And not long after that, people started doing things like this, trying to create lots of photos, one after the other, so that you could have multiple photographs that you can play after each other or look at each other. So that one over there takes 12 photographs after each other. And this is a photographic gun. What's it called? Chronophotography, like photography over time. And you can use this to take photographs of birds flying. And they also used it in the First World War to practice shooting enemy planes. Instead of using bullets, you could just take photographs of the enemy planes, and then you can, during practice runs, and see if you hit them, and it didn't cost any bullets. So these were one of the first couple of ways to create multiple photos over time, and that results in stuff like this. So this is one of the first moving pictures, the horse in motion. And this is the way we look at it, because we have a display that can show multiple photos. But most of the time, when people back in those days looked at it, they just saw those, because there was no display device. You had those devices where you can rotate a thing and look through a slide, but if you just print it in some magazine, then that's what it looks like. Or you can overlay all the photos on top of each other. And that way you can also see what something looks like. And this was often used for scientific research, like how do people actually move? Because you can't see it, you need to make, if you look at somebody pole jumping, you don't know exactly what they do, but if you make a lot of photographs, then you can look back in time and see what happened. Same for how do birds actually fly. So back in those days, there was the first usage of motion video was for scientific research, and then over time also for the stuff we use it now. Actually, these kind of pictures are really cool. This is one from 1 or 2 weeks ago when a rocket, 70-meter tall rocket, fell back from space and was caught by 2 little chopsticks. And this is a composite photo of that. So yeah, I, together with Matthijs, we have a company called Nonstrict, and we build apps. These are 2 of those apps. Basil is an app for, is a Mac app. You can plug in your iPhone to your Mac, and then your iPhone shows up on your Mac, and you can see a live mirror of your iPhone. We recently added recording to that so that you can record what's on your iPhone, and it includes a nice bezel around it. And if you, like you rotate your phone, it's a whole video gets created with a nice rotating phone. So that's a lot of video stuff. This is another app, Split Screen. We built this together with Jordi Bruin. This is an app for your Vision Pro, where it mirrors or it creates a second display in your Vision Pro of your Mac. So if you use Apple's Mac Virtual Display, you have one display, but if you want a second one, you can use Split Screen, and it wirelessly sends a second video from your Mac to your Vision Pro. So we do a lot of video stuff, and that's what I want to talk about, how video actually works under the hood. So yes, so what I wanted to do was just code and build some video stuff out of nothing, basically. So yeah, I have a lot of stuff I want to code. I printed some of it out for me to remember. I have some other tabs open of commented out code which I want to copy paste. We'll see how well this goes. If you have some questions about something I'm doing because it's not clear, then please ask it. I'll repeat the question. Because if you don't ask the question, I just keep going and then we might lose what we're talking about. Yeah. Okay, so let's see, Xcode. Okay, so this is the app. This is basically the standard Hello World app. Doesn't do anything yet. And I want to create a video, a motion, a moving picture. But like we saw before, a video is nothing more than a series of images. So we start by creating an image. And what is an image? Yeah, actually, what is an image? Who knows the answer? What is an image fundamentally? What do you think? A picture, a bitmap? Yeah. Colors in a certain resolution, so 920 by 180 is just that you create colors. Yes. Yes, black and white are colors in our, for our use case, black and white are colors, definitely. Okay, so yes, colors in a grid, and we call those pixels. So let's just build that. Okay, so struct color. Here, let's create a color. What is a color? Red, green, and blue. Let's do it easy. uint8, sure, that's a byte. Now we can have 256, yeah. Different colors of reds, green, blue, sure. Okay, so now we have a color. Yeah, this is a color. Let's make some colors. So extension color, static, let black. Yeah, this is black, right? What did you say? White is also a color, sure. This is white. So if you know those hex colors where you have FF000, that is this, but now in byte format, in integer format. So yeah, let's red, sure. I really like this new, it just knows, this is green, sure. Blue, whatever. Yeah, okay, so this, now we have a bunch of colors. Now we can create colors, our own colors, not Swift colors, Swift UI's colors. Okay, but we wanted to create an image, so we want to create a bitmap. So let's do that, bitmap. A bitmap is an array of pixels, and each pixel is a color. And we need one more thing, because now we have one long bitmap, but we need dimensions like width and height. Otherwise, we don't know, is this one pixel all the way or does it wrap around? So we can have a width and a height. And actually the height is all the colors divided by the width. That is what the height is. Okay, so this is a bitmap. Everything clear so far. This, yeah, it's starting to look like an image somewhat, not yet. Let's do some more helper stuff like yeah, okay, so now we have an image that's all black of a certain width and height. If we want to change individual pixels, we can do that too. So this Xcode is tremendous here. So now we have a subscript, which means we can access the, if we have a bitmap, access it like so. We can do stuff like self set the first pixel to white because of this subscript. Okay, so now we have a bitmap, but I want to create an actual image, not some big black square rectangle. So I want to create the Dutch flag because I'm a proud Dutchman, also because it's a very easy thing to create. So let's do a flag. Func flag. Flag is a bitmap. Let's make it 920 because we want to do a full HD video. Yeah, no, okay, not this one. I want multiple stripes because the Dutch flag is 3 stripes. And the pixels are an array repeating. Not okay. Now it's going wrong. A single stripe, a single red stripe. That is the width of our image times the number a third of the height. So now we have a red bar here, and we can do white and do blue. And now we do return bitmap pixels width. Now we have a very beautiful Dutch flag. Doesn't it look amazing? Except we can't see it yet, so we need to change to show it. And to show something in on iOS, we are like here. We need, if we have an image like this, we need to use the image tag in SwiftUI. Or if we use UIKit, we use a UI image. On the Mac, we use an NS image. And behind all that is a CG image, which is a core graphics image. So if we can turn this into a core graphics image, then we can ultimately show it on screen. And to do that, we will create a function, create CG image from bitmap, exactly. So what we need is, now we need to do some technical stuff to make it a CG image, and it's interesting to see how it works, so I just want to type it out. Bytes per pixel, the number of bytes per pixel is exactly the stride of the memory layout. The bytes, actually bytes per pixel I want to call it. It helps the magical autocomplete. The bytes per row is the exactly this. We have data in memory, which is, if you've ever used the data thing in the bitmap pixels, and it consists of the bytes per row times the bitmap height. So now we have turned our pixel array into a data array that we use, or a data object, but it's still basically the same shape. And now we can take this data and create an CG image from that. So if we create, this is CG image stuff that you just need to know to make it work. But you just keep pressing tab and it magically fixes it. Actually it's not correct, I see. Okay, so the CG, the CG image constructor takes a bunch of arguments. So the width is the bitmap width, the height is the height, the bits per component. So these things are the components, and they are uint8, which is a byte, which is 8-bit. So that means there's this many bits per component, 8. The bits per pixel is the number of bytes per pixel times 8. The bytes per row is correct. The color space is RGB, which is indeed what we want. The bitmap info, we can use this for alpha, but we don't have transparency in the image. What else is there? Okay, if it doesn't complete, I don't know what to type. Escape. Oh, great. Okay, that's fantastic. Escape. Provider. Yeah, that's the provider created above. Escape. Decode. We don't need to decode anything. Should interpolate, sure, and the defaults. I don't know what this is. This is this part of the code is from. Oh, I forgot his name. That's very unfortunate. I saw it on Objective-CIO. They have a great series on how to do video games, how to create video games, and which also starts off like this. And that's where I got this from. Nick, what's his name? Yeah, Chris Eithoff does the talk, but he did it together with Nick. Yes, Lockwood. Yes. Yeah, exactly. Nick Woodlook, and he did this this as well. So add a bunch of exclamation marks, and now we have a CG image. And now that we have a CG image, we can actually show it. So if we have an extension on the Swift image, we can have an initializer that takes a bitmap and that does this decorative create CG image from bitmap. The scale of the image is 1. And now instead of this globe here, we'll just do a flag. And we have a flag. So this already, I think, is really cool. Do I have a slide for this? I think so. Yes. So because this is compressed pixel data, and we just wrote it out by hand like this, but this is also the way stuff works in memory. If you have, like, if you have a camera feed coming in from a webcam or from the MacBook camera or on your iPhone from your camera, it comes in basically the same data structure. If you're screen recording on Mac, it gives you the same data structure. It's uncompressed pixel buffer data that you need to deal with. And one thing you can do is just show it on screen, because in the graphics card it's also uncompressed pixel data. And this is doable to directly show it on screen. Except it's kind of boring. So I have a little, here's my helper stuff. Let's make it a little bit nicer. Where is it? So the fancy flag function we have here, I'll just modify it a bit. So I added a sign function so that now the flag can wave. And now the flag does a little nice wave. And the way this works, you don't need to read this, but it's just moving pixels a bit based on the way you are in the sign. And actually, because we're in Swift UI, we can do something like a timeline view, have an animation that takes in a context and pass the context date in there, and then the flag function, give it a time. And now the flag is moving. We have a motion picture. And this works because it's SwiftUI, and SwiftUI just calls our flag function every time it updates the UI. I don't know how often this happens, probably once per render frame, 60 times per second. But if SwiftUI is busy and it skips a frame, or my app is blocking the main thread or the render thread or something, then it would just skip a frame, move a bit, but the time that gets passed in here still correct. So it would just have a little jump in the video, but you would still see this nice animation. So this works. One thing that's interesting is how much data is actually going through, because now this is all uncompressed video memory. So to look that up, I have this function. Let's just print it. So this is all the data going by. I have the bytes per pixel times the resolution of this image, which is full HD, times 60, because we're doing 60 frames per second, times the number of seconds that has passed. So yeah, that's a lot of data. It's going by, it's not being kept in memory, because every time it updates, it creates a new image. But this also makes it clear why, if you have a big external monitor with a very high resolution, you need a fat wire Thunderbolt cable, because it needs to put a lot of data through that cable, and it's all uncompressed image data. Okay, so if we want, this is now SwiftUI, but if we want to create a video file, we need to save it. But this is starting to get a lot of data. We can't just save it like this. I mean, we can, but yeah, your hard disk will fill up quickly. Yeah, okay, so now I want to move on to the next part, which is saving it. And for that I have this button, make video, which calls this function over here, which currently doesn't do anything. It creates a file called movie, and that's it, which has no data in it. But what I want to do is create a video from this nice flag animation that we have here. And I'll just create a 60-second video, which is 60 frames, and we'll save that. 1 second video. So, yeah, I said a minute. Okay, 1 second of video. So actually, let's see how much data that would be. 1 second of video would be, in this format, 356 megabytes, which I also don't want to store to disk, because my disk is almost full. Let's create, so I need all those video frames, and I'll create them, because we have a function for that anyway. So I want to call the bitmap function flag, but I need a time. This isn't good. I want the time, which is 1 divided by 60. I don't know how to do floats, how to make sure they're floats, but now they are. Okay, so now I'm creating the bitmaps, 60 bitmaps, which is that many megabytes, and I'll turn them into JPEGs, because then I can save those to disk. That's a lot smaller than bitmaps. So I need a CG image, which is the create CG image function from the bitmap. Then I can create a UI image from the CG image. And then I can create data from the UI image, which has a nice useful function for that. Now I have JPEG data, and I can let's just print it to know that it's working, and then write it to a file. It's optional. Now it's not. Write to in my directory. I want a pending pending path a file called image.jpg. Okay. So I'll run the app and hit make video and tab over to the directory. And now it starts creating all the video frames. And here it's looping and now it's done. It took 6 seconds to do that. This isn't the most efficient way to create a 1-second video, but now we have, I can just click through them. I have a very slow, but it's, I mean, if JPEG, I have 60 JPEG frames for each part of the video, and it's working. And also, if I look at this directory, it is just 4 megabytes. So that's like a 10th or a hundredth almost of the data. So this is a way more efficient format to use to create JPEGs for instead of creating bitmaps. And this is my second thing, because this is already very useful. If you have like a live webcam feed, they often use MJPEG or MJPEG videos, which are just JPEGs one after each other. If you have a Raspberry Pi with a webcam, they also often have this format. If you have an MJPEG, you can just show it in an image stack on your website, and all that is an open socket, an open HTTP request to which JPEGs are written. And that works really well because a single image like this is only 67 kilobytes and 4 megabytes per second. And this is a full resolution. If you have a smaller resolution, it wouldn't be that much data. So this is already a big upgrade over the previous way, and already very useful. And what this is basically is we have keyframes. The keyframe is the whole image. So we have the whole image for every time, every single video part we want to show, we show the whole image. And this is basically the same way like those photographs work from the 1800s. And if you compress it like in JPEG, that's useful already. But we can do better because we have video compression APIs. And the way they work is you have, instead of keyframes every time, you create delta frames, like the difference, store only the difference from the previous frame. In this example, a lot of the part is red and never changes, and the other part is white and never changes, and the other part is blue and never changes. And you only need to store the differences. And that's what video compression does. The keyframes are called iframes, and the p frames only contain the differences from the previous frames. Yeah, so, and the way we do that with Apple's APIs, there is a thing called a VT compression session from Video Toolbox, which is an object you can create, and then you can call the encode frame function on it. So the reason you need to create an object, because like the code I just showed, you can just call create JPEG on every frame and that works, but now we need to create an object because it needs memory. The session object retains what the previous frame was, and then it can calculate the difference from the subsequent frames that are passed in. So you need to have a session object and call the encode frame function on it each time. And then you get back a compressed video frame. So here we don't need to read all this, but because Video Toolbox is all C code and it's not nice Objective-C or Swift code with objects, it's all functions like this. Video compression session create, give it a bunch of arguments. It is a weird syntax for setting properties. I put it all in this function, create a compression session, and then there's a function called encode frame, which calls Apple's VT compression session encodes frame function. And I just wrapped it so I can make it asynchronous, which is easier to do with than a callback. So let's do that. So instead of all this JPEG stuff, I'll create a compression session. Try create compression session. The compression session needs a thing called a pixel buffer, but that's just a wrapper around the same data that we had before, similar to a CG image. It wraps the data from the bitmap. So I'll create a pixel buffer from the CG image. Pixel buffer. And now I can pass it on to the compression session. So it returns a sample buffer, which I know try await session encode frame pixel buffer. And this actually needs a time argument, because now previously we were just saving JPEGs to the file system, and the rate at which I was showing them was this, the rate I was clicking the next button. But now we need to pass in the time so that the video knows when to show the next frame. So if you have 60 frames per second, you need to give a time that moves ahead 60 times a second. But you can also have, if nothing changes on screen, just don't output new video frames, and then the next frame you show, you just give a time that's a long way ahead. That way you don't only need to change store a new frame if something changes, and passing time. So I have a time here, I can pass it in. Also, this returns a sample buffer thing, but it's optional because the session can drop frames. If my hardware is busy, my Mac is busy, there's hardware video encoders in here. If they're busy, you just don't have the time to encode the frame, then it might drop a frame. But yeah, that's fine. I'll just do if let sample buffer. This sample buffer is again a little wrapper object from Apple that has the encoded data and some information about the time and other stuff. And if I want to turn that into data, I can store to disk. I have again a helper function for that. Convert to NXB. NXB is a sort of a informal format of how to encode video to data, so that you can store it or transfer it over the network. So now I have data. And data I can write, so I have a file handle, write the data to it. Doesn't even throw. Cool. Okay, let's try. Let's see if this works. Make video. Actually, I should clean this directory first. Make video. Is it doing anything? I don't know. I should. Okay. Let me. I have a progress method. Oh, it was done. Okay, let's do it again. Click, click, miss, go. Why is it not working?
Is there something about fallbacks?
Oh, I always ignore all this stuff. Okay, now it's working. Okay, so it's creating data. This is for each video frame this many bytes. I don't know how much that is. It's done. And now I have a movie file which is 200 kilobytes. but let's see what this looks like. Except this isn't a normal movie file. This isn't something I can double click on because it doesn't have any container format. If you use QuickTime or like an MP4 file or an MOV file, those are all called container formats because they contain the video data, but also audio data, maybe subtitle tracks, lots of stuff. This is just the raw video data. But there's in FFmpeg, there's a bunch of tools that can deal with that. So I'll use FFplay, which can handle this. So let's see. We have a video file. So that's a 1 second video file, but now we went from 350 megabytes to 4 megabytes for the 350 for the uncompressed, 4 megabytes for the compressed JPEGs, and now 204 kilobytes for the same video, but now compressed using H.264 video compression. And this is something that we can transmit over the internet and or live stream to somebody else or do something with, because now it's all the same data. It looks basically the same. If you look at the pixels, you'll see some video compression, but it looks basically the same, and it still works. Yeah, okay, so this works. One thing I can do is just change the source. I was doing this create image here. I can also do await pixel buffer in camera feeds. So now I have pixel buffers here. I don't have the I anymore. I don't have this anymore. And the time is the date, time interval since when I started. Don't need this anymore. Okay, so now I have the same code to create a video from my camera feed. So if I just start it here and click here, and now I wait. Oh, I see the light going on. It's working, I think. I don't know, let's see. It's working. So this is the delayed video. And it just keeps going. Okay, this is a live stream, yeah. And there's no way, this isn't ending because, yeah, I'm now streaming it live. It's just going through this loop, writing through that file, which I'm playing back here. The file is getting bigger and bigger, yeah, exactly. I don't, it says 0 bytes, this is amazing. I don't believe it. The file is still being written to. So I can, if I just stop, I don't know how long this is. How do I stop? Stop. Let's see how big the file turned out to be. For 500 megabytes. So, yeah, this is full HD video, 500 megabytes for however long that recording was. If I want to have a smaller file, I can reduce the resolution or increase the compression or change to a different video codec that is more efficient. Yeah.
You mentioned you have keyframes.
Yes.
And is this something that you can also provide to the thing to be so it becomes more efficient? Or if there's, for example, a scene change in your live feed, does it figure it out itself on, hey, this is
Yes.
specifically for keyframes?
So by default, it will. Well, there's so much you can configure to the compression session. So by default, it will just figure stuff out. But you can also say, hey, I know something changed. I want to force a keyframe here. For the live streaming stuff that we do, for example, to stream video from the Mac to the Vision Pro, if on the Mac the video compression starts, it creates a keyframe and then starts sending the differences. But then if you disconnect on your Vision and you reconnect again, you don't have the initial keyframe. So it will look like those strange videos you sometimes see that are just moving stuff around because it doesn't have a keyframe. So for that, in that example, we from the vision send a command back to say, hey, create a keyframe, I need one. Or on the Mac, see, hey, somebody new connected, let's force a keyframe now. So you can really optimize that. Yeah, there's a lot of options there. So yeah, that was the recap. You have uncompressed pixel buffer data. That's the stuff in CG images. That's what macOS deals with or iOS deals with all the time. If you read a UI image from a JPEG or from an asset catalog, to render it to screen, it needs to uncompress it, so it turns it into a CG image that at some point will be uncompressed. It really depends on when it will be uncompressed, but by the time you see it, it's uncompressed. You can just compress individual frames, and it's already very useful, like a Raspberry Pi webcam feed, or use an actual video compression to like H.264 or H.265 to compress video. Yeah, and after that you can do things like write it to a file to create a movie file using AV Asset Writer, or stream it to a video. If you create a HLS stream, that's a live video that somebody can, you can write to a server and then somebody can stream it from a server or stream it over the network. This is what we do for like the Vision Pro that you can see stuff on your Mac. We create data from it and stream it over the network. So if you're interested in this, I encourage you to look at Apple's talks, because they have a lot of talks. This is one of them, direct access to video encoding and decoding from 2014, which I'm happy to see is still online or back online. They put a bunch of sessions back online, but they also take sessions go offline. So we made a website, WWDC Index, that shows all sessions that Apple ever had since 2000, the year 2000. And you can browse that if you want to see some, look for some specific talk. And usually, even if they don't show the talk on the Apple developer app anymore, it's still hosted on the CDN, so we have links to all the CDN over there, so you can still see all the videos. So if you're interested in something like this, lots of talks are from earlier, because nothing changed since like 2005 when they introduced something. So, but the talk is still relevant. But this is a great talk about introducing all the video compression stuff. Yeah, that's it. Thank you very much. No? Who's gonna compress some videos?
Tom, you got other questions?
Sorry?
You got more questions? Okay, well then in that case, thank you very much, Tom, for the very clear explanation, because there's no questions. So, oh, one.
So when you were creating Bezel for this, or Bezel, however you pronounce it, so what would you say is like the biggest part of your code? Is that the network stuff, or is that the compression stuff? The streaming all the data?
Bezel currently works via wire, so there's no network transfer stuff. Just so for yeah, people want wireless. We've heard your questions, your requests. So what is the most stuff? So, like you need, like for the split screen to wirelessly stream video to the Vision, you need to do basically this, what I just showed, compress the video and then create data from it, send it over the network. But that's something you figure out once. Now there's a cool open source project from Finn Voorhees called Transcoding, I think. It's on GitHub, which basically does this. You give it uncompressed video data from some source, and then it turns it into data that you can send over the network. It's a little bit of code. It's difficult to figure out initially if you don't have any examples, but then you can reuse it. We reuse it all the time. Okay, Matthijs is a better answer.
Yeah, well, I wanted to add that, so the video compression stuff, there is a more high-level API for that. So if you're going to write out video, you probably want to start out with a higher-level API, like AV asset writer, or there's even, I think, a movie file writer. So that's pretty easy to get started with. For all the sending stuff over the network, you're pretty much on your own. There is no easy Apple API for that. So in terms of how many time did it take you to send stuff over the network, then it's definitely took more time to do the networking stuff, because that's something you have to do all yourself. That NXB stream Tom wrote out, that's something you just have to do yourself. There's no API for that.
Yeah, and if you just want to record a video, like on your iPhone, then there's a lot better APIs than these.
Don't start out with your own bitmap.
Don't start creating bitmaps and colors. There's a lot better APIs, but the AV capture session is an easy one that you can just give a camera to, give a file to, and it does it. Creates a file from your camera and compresses it. Okay, thank you very much.